The question here is that it says that you have to calculate the value of the integration from y varying from 0 to 1, x varying from 0 to 1 minus y square, y sine pi 1 minus x whole square dx dy. I'm sorry, here it should not be x square, it should be 1 minus x whole square. So 1 minus x whole square dx dy. This is equal to which of these four solutions, right? So here, can you try and solve this question by yourself? This is performing simple double integration where this function is given to you, y sine of pi 1 minus x whole square dx dy. If you try to solve this question directly, integration varies from 0 to y and x integration limits varies from 0 to 1 minus y square. You have y sine, in angle you have pi into 1 minus x whole square dx dy. So when you firstly perform the integration with respect to x, this quantity 1 minus x square in the angle will create a problem and you are not directly able to calculate the integration. So what can be done here in order to calculate this integration? So here, if you wanted to solve this integral, firstly what we will do, we will change the order of limits and we can try to solve the question in that way. So by doing so, you will calculate the variable limits in y and you will calculate the constant limits in x, and so that you could perform the integration, right? So let's first do that. So for that we require an integral where we have variable limits in y, constant limits in x. The function would be as such, y into sine of pi 1 minus x whole square. Now instead of dx dy, we will have dy dx. So let us now first determine what are these two limits. So for that, we have to visualize the given limits or the given region. So here for the region, if you look at your earlier limits, so it has x is equal to 0, it has x is equal to 1 minus y square, it has the value y is equal to 0 and y is equal to 1. So using these equations, we can now draw the corresponding region. So this is our y-axis, this is the x-axis, right? This point is origin. Now x is equal to 0 means we are talking about this y-axis only. So this is your x is equal to 0. Y is equal to 0 means we are talking about this x-axis, and suppose this is the point 1 on y-axis. So y is equal to 1 would be a straight line passing through 1 on the y-axis and parallel to x-axis. So this line also, it would move in this direction also. So these are your lines. Y is equal to 0, y is equal to 1, x is equal to 0. Now for the fourth curve, you have x is equal to 1 minus y square. Now one variable is in square, another is having degree 1. So that means it could be a parabola. In fact, it is a parabola and you could rearrange the limits. So you can write this to be y square is equal to minus x minus 1. So that means this is a horizontal parabola in the direction, in the closed direction towards the negative x-axis, right? So here, if this 1 was not present, that means if we had this curve y square is equal to minus x, then the parabola would simply be like this. But now because it is minus 1 in the x coordinate, so that means the x coordinate, the vertex has been shifted to 1 units to the right. So that means we have, instead of this parabola starting from 1, we have it starting from positive 1 on the x-axis. And moreover, it will cut this y-axis at which points? So at y-axis, the value of x is 0. So when when the value of x is 0, you have this to be y square. So you have y square as equal to plus 1. So that means y is either equal to plus 1 or minus 1. So at this point, this parabola will meet this y-axis, and at this point minus 1, this parabola will meet at the y-axis. So your parabola would go something like this. So what is your shaded region? The region which lies between the parabola, whose equation is given to be, I can write this to be y square is equal to minus x minus 1. Right? So, and so this is the equation of this parabola, and moreover we have y is equal to 0 as this line, x is equal to 0 as this line, and y is equal to 1 is also covering this region. So this is the region of interest here. Now here, in order to calculate the limits, variable limits of y, what we are to do, we are to take a vertical arrow. So when you take the vertical arrow, you will see at which point it enters this region. So here at this point, the value of y is equal to 0, right? Because this is the equation, y is equal to 0. So we have our lower limit as equal to 0, and the upper limit of y, that would be calculated from this equation of parabola. So from this equation of parabola, you have y square is equal to 1 minus x, or in other words, you have y is equal to plus minus square root of 1 minus y. So we'll only consider the positive branch of this parabola. Why? Because we are in the first quadrant. If we were here, so we would have considered the negative branch. So here the value of y is plus square root of 1 minus x. And the limits for x, they vary from 0 to the point 1, because this is where your region has been covered. So we are having the value of x from 0 to 1. So now let us try and solve this portion. So firstly, we'll perform the integration with respect to y. So that means these terms would remain as such, and moreover it does not contain y, so this term would also come as such. So what we are left with here is y. So integration of y with respect to y is y square by 2, and we have the limits of y varying from 0 to 1 minus square root of 1 minus x. So this quantity would simply be equal to integration x varying from 0 to 1 dx, and this 1 by 2 could be taken outside. So y square, when you substitute the upper limit, it would be 1 minus x. When you substitute the lower limit, it would be 0. So you have 1 minus x into sine of pi 1 minus x whole square. Right. So now can you perform the integration with respect to x here? So it would be easily obtained if you substitute 1 minus x whole square as equal to some other variable, because this thing here was creating problem. Because we as such directly know what is the integration of sine of pi of t square, right, or x square. So in order to remove this square quantity, we are making a substitution. 1 minus x whole square is equal to t, so that we have 2 into 1 minus x into minus 1 into dx is equal to dt by differentiating this quantity. And moreover, whenever the value of x is 0, that means your t is equal to 1, and whenever x is equal to 1, your t is equal to 0. So we also obtained the limits for these quantities. So therefore our integration here, the limits, they reduces from t varying from 1 to 0, and this quantity 1 minus x dx now could be written as dt by minus 2, right? And in place of this sine pi 1 minus x whole square, I can write sine pi t, right? So this become minus 1 by 4 integration. This minus can be absorbed to invert the limits. So I can write plus 1 by 4 integration limits from t varying from 0 to 1 sine of pi t dt, right? So here, what is the integration of sine? It is minus cos pi t, and you also have to divide by the angle. So the limits of t, they vary from 0 to 1. So you have minus 1 by 4 pi, right? And you will substitute the upper and lower limit. So it would be cos pi minus cos 0. So it would be minus 1 upon 4 pi minus 2. So this would be equal to 1 upon 2 pi. So here 1 upon 2 pi is the answer to your question. So let's have a look at our options. So here option A is the correct option, right?